Here you see the important inputs and outputs of this problem. If I want to connect this slide to mathematical modeling, you remember in that topic we had two types of parameters, controllable and uncontrollable. The uncontrollable parameters were something, for example, in the case of standard and deluxe golf bags, the amount of time needs to manufacture a standard bag in each of those four departments were uncontrollable, was uncontrollable, or the fact that we had four processing departments was uncontrollable. But the number of standard bags, the number of deluxe bags being manufactured were controllable, and we called controllable variables as decision variables and the other one as inputs. So here it's exactly the same thing. Here we have decision variables, that is, as you can see here, replenishment level, that is Q. Another parameter that is very important and is input is demand. That is a random variable and it is uncontrollable. And the other things that are output, they are not input, are the average monthly net profit and the service level. They are going to be output. So based on this and this, that this one is random and this one is controllable, random and uncontrollable, and this is constant and controllable, we have this one to get these two. And according to the two things that we get, the service level and average monthly net profit, we decide what is the best replenishment level. And finally, we make decision on this thing because this is decision variable. With our simulation case, two scenarios could happen. In one of them, the demand in that period is equal or smaller than the Q, that is replenishment level, and the other one is the scenario in which demand is greater than Q. So when we want to do this, when D is smaller than Q, it means that you have higher inventory in comparison to the demand that you have. Okay, obviously you can satisfy all the demand because your inventory is high. And as you can see here, Q, that is your inventory level, is higher than demand. So you have no problem in satisfying all the demand. So you don't have any shortage cost. You just have inventory cost or holding cost, as you can see here. Since you satisfy all the demand, the gross profit would be 50 times D. D is because, let me show you with this. Okay, D, because it is the number of routers that you are selling, and with each router you are gonna make $50 according to the description we had in the case slide, because it was 125 the selling price minus 75 the cost, so the gross profit would be $50. So the total amount, the gross profit, or the no, gross profit is a good word for that. The gross profit is, I wanted to say about income, but no, because it is deducting some part of the cost from 125. So gross profit that we have is $50 times D, the number of sale, and it is the sale, and 50 is the gross profit for each router. So we have this, since we satisfy all the demand, there is no shortage loss, so there would be only holding cost. Why we have holding cost? Because the inventory that you have is higher than the demand. So obviously at the end of the period, you only have holding costs because the inventory is higher than the demand. So obviously, for example, if it is 100 and you have sold 80 of them, at the end of the period, you will have 20 router and you need to pay the inventory cost for them. So you have the gross profit and you have the holding cost. If you deduct holding cost from gross profit, you get net profit. So net profit equals gross profit minus holding cost, 50D minus the holding cost. So what is the holding cost? As I told you, if you have inventory of 100 that is higher than demand and you have demand of 80, so you need to pay holding cost for the 20 router that you have. So this part that you see is exactly the same thing. So it is nothing. Q is the inventory cost minus demand that you have times $15 that you pay for each router that stays in your inventory at the end of the period. Same thing happens to the other scenario. Just here, the demand is greater than Q. So when you want to do the calculation, since the demand is greater than Q, so the inventory level that you have cannot satisfy all the demand. So at the end of the period, the level of inventory would be zero because you will give all the inventory that you have and you have zero inventory, in a way that you are going to lose the coming demands that are coming. So you are not going to pay anything for inventory holding because your inventory is zero, but you are gonna pay shortage cost. So since demand is greater than Q, demand is not a factor to determine the gross profit. The gross profit would be the total sale that you have. You have Q as the inventory level and you have D as the demand and you have Q as the inventory level. Demand is greater, so you just gonna sell Q, and on each router you are gonna make 50, so the gross profit that you have is 50 times Q. Completely common sense. And again, as I told you, there is zero holding cost, but about the shortage cost, just imagine you have demand of 100 and you have inventory level of 80. So of course, you can only satisfy 80 units of your demand, and you are gonna lose the remaining 20 the 20 routers demand that you calculated 100 minus 80, and that is demand minus Q. And since D here, as you can see, greater than Q, this is always a positive, and for each unit that you lose, you have to pay the shortage cost of $30. So $30 times D minus Q, and on the other hand, you have the net profit. The net profit would be gross profit minus shortage cost, exactly the same as the previous one minus, and you have this. And now you have these two things to calculate the net profit in each simulation case. Now we are very close to wrapping up this simulation model, because now you know how to calculate the net profit in totally two different cases that could happen: D equal or smaller than Q and D greater than Q. Here you see the flowchart for doing the simulation model. Here it starts with setting the model parameters, the ones that are not controllable, as we talked about. So here we have the uncontrollable parameters. It says set the gross profit as 50 per unit, $50 per unit, holding cost $15 per unit, and shortage cost $30 per unit. It is not something new. In the scenarios that we just discussed, when D is equal or smaller than Q and the other one was D greater than Q, we considered all of those things. So this flowchart that you see in front of you is just a review over everything that we have done together. And so they are set, and when you set your model, simulation model design in a good way, for example, next year the gross profit would be 60 per unit. Very easily with changing that part, you can have your model completely refreshed without making a new model. So you just going and change that part. So that's the reason you see it says set them as this amount, because in case of any change, you just go and change that parameter over there. But it is not the focus of our course this semester, because we just focus on the simulation modeling, not development, efficiency, and all those things. But it's a good point that it is telling you. Another one that is telling you is select a replenishment level queue. That's correct, because in your simulation, you are gonna try different levels of inventory. For example, you start with 50. You see that if replenishment Q is 50, okay, what would be the average net profit? After that, you go for 100. See the results: 150, 120, 80, and finally, we are going to check it together. You will understand how you are going to do it. For example, when you put 80, you get a number. You put 100, you get a better number. So you continue increasing the inventory level. You go for 120. You see still it is increasing. So you go for 150. You see it is decreasing. So you go for something between 120 and 150, and like that you find it in a chasing style to find the best one. It is like playing a game. So select a replenishment queues. Now you have your replenishment level queue, and after that you start doing the simulation. Generate the monthly demand. Check if D is smaller or equal than Q or not. If yes, you are gonna calculate the net profit according to the previous slides that we discussed together, my friend. And if D is greater than no, because when D is smaller than Q, there would be holding cost because Q is greater than D. And otherwise, if D is greater, there would be shortage cost. So we get there, and so now you have calculated the monthly result, and you see it says, is it month 1000? No. So go and do it for next month and repeat this cycle for 1000 times. So you come up with 1000 simulation, and after that you compute the average net profit, and that's it. That's the reason I always say simulation is super easy if you have a good understanding of the world around yourself and the common sense. And when I say the world around yourself, not in terms of being updated about the things that is happening around us, just know, for example, just this common sense that if demand is greater than Q, so you don't have any inventory cost because demand is greater than Q, and at the end of the term your Q would be 0 and you don't have to pay any inventory cost, and you just have to pay the shortage cost.